Welcome to the TOEFL Listening section. In this section, you will listen to an academic lecture and then answer questions about what you heard. You may take notes while you listen. You will have time to review your notes before answering the questions. Listen to part of a lecture in a university class. You will hear the lecture only once, so listen carefully. After the lecture, you will answer some questions about what you heard. Some questions ask about the main ideas and supporting details. Other questions ask you to make inferences or connections between ideas. Answer each question based on what is stated or implied in the lecture.
Today we will focus on vitamin functions and why these small molecules are vital to physiological processes and public health. I want to emphasize function rather than dietary sources. We will look at biochemical roles, clinical consequences of deficiency, and a few real-world applications in clinical nutrition and public health. First, consider a broad division. Fat-soluble vitamins include A, D, E, and K, and they often act as regulators or membrane protectors. Water-soluble vitamins include the B complex and vitamin C. Many B vitamins act as coenzymes in metabolic reactions, which explains why deficiencies impair energy production. Vitamin A has two principal functional roles. One is in the visual cycle, where retinol combines with opsin to permit phototransduction. The other is as retinoic acid, which modulates gene expression in epithelial differentiation. Clinically, this explains why vitamin A deficiency causes night blindness and epithelial degeneration, such as xerophthalmia. Vitamin D is unusual because it is converted to an active hormone, calcitriol. Calcitriol regulates calcium and phosphate homeostasis by influencing intestinal absorption and bone remodeling. A lack of vitamin D impairs mineralization and leads to rickets in children and osteomalacia in adults. Vitamin E functions primarily as a lipid-soluble antioxidant. It protects polyunsaturated fatty acids in cell membranes from oxidative damage. This role is especially important in tissues with high oxygen exposure, such as the lungs, and in red blood cell membranes. Vitamin K has a very specific enzymatic role. It is required for gamma carboxylation of glutamate residues on clotting factors and on bone proteins such as osteocalcin. Without this modification, clotting factors cannot bind calcium, and coagulation is impaired. Now, vitamin C has two interrelated functions. It is an antioxidant and a reducing agent, and it also serves as a cofactor for enzymes that hydroxylate proline and lysine in collagen synthesis. Vitamin C is a cofactor for prolyl hydroxylase, which stabilizes collagen, and that explains why scurvy causes bleeding gums and poor wound healing. Vitamin C also reduces ferric iron to ferrous iron, which improves non-heme iron absorption in the gut. That biochemical role links vitamin C status to iron nutrition in a clinically meaningful way. Turning to the B complex, thiamine, or vitamin B1, is converted to thiamine pyrophosphate, which is essential for pyruvate dehydrogenase and alpha-ketoglutarate dehydrogenase. These enzymes link glycolysis to the citric acid cycle, so thiamine deficiency produces prominent energy metabolism defects and conditions such as beriberi and the Wernicke-Korsakoff syndrome. Riboflavin and niacin form FAD and NAD cofactors that participate in redox chemistry throughout metabolism. Pyridoxine, or vitamin B6, becomes pyridoxal phosphate and is central to amino acid metabolism and neurotransmitter synthesis. Deficiencies therefore present with neurological and hematological signs. Folate and vitamin B12 are functionally linked through one-carbon metabolism. Folate is required for nucleotide synthesis and methylation reactions. B12 acts as a cofactor for methionine synthase and methylmalonyl CoA mutase. Folate deficiency in early pregnancy is the key preventable risk factor for neural tube defects, and supplementation programs have reduced incidence in many countries. An important clinical implication is that many B vitamins act together as coenzymes and are water-soluble and therefore less likely to accumulate to toxic levels than fat-soluble vitamins. By contrast, fat-soluble vitamins can be stored and may cause toxicity when excess intake persists. I will give a short case example. A community with limited sunlight exposure developed higher rates of rickets. Public health officials introduced vitamin D fortification and supplementation in infants and saw a decline in rickets cases. This illustrates how understanding vitamin function leads directly to effective interventions. To summarize, vitamin functions vary from acting as coenzymes in energy metabolism to regulating gene expression, to serving as antioxidants, and to enabling post-translational modifications required for blood clotting and structural protein stability. Recognizing these roles helps clinicians diagnose deficiency states from symptoms and guides public health measures such as fortification and targeted supplementation. That concludes the lecture portion on vitamin functions. We will now move to questions and discussion.
Listen again to part of the lecture. Then, answer the question.
Vitamin C is a cofactor for prolyl hydroxylase, which stabilizes collagen, and that explains why scurvy causes bleeding gums and poor wound healing.
This concludes the listening section. For more TOEFL practice tests and study materials, visit Spinta.org.